Okay students, let us start today's topic, that is continuity and differentiability, and this is again one of those topics which is not asked at a very difficult level at JEE Mains. In fact, basic questions are being asked, so our target for this particular lecture would also be to understand the basics of continuity and differentiability. And though the concept, if we talk about the concept, there are only just two concepts, that is one is of the continuity and the other of the differentiability. The rest all are the problems in this particular chapter. So let's start with first of all continuity. We'll do some questions based on continuity, differentiability and a mix of them. Let's start with continuity first. Okay, now let us first of all understand what do you mean by continuity, right? So if I ask you, anybody, let's say for that matter, what is continuity, so how you will define me? So there is a graphical method. If I have to talk about graphs, right, if I have to tell this to you graphically, so I can say this graphically. If you can draw the graph without lifting the pen, if you can draw without lifting the pen, that means the graph is continuous without lifting the pen, right? So then that becomes the continuous function. So for example, I have 4 diagrams in front of you. So this first diagram, you can draw this curve without lifting the pen. For this second curve, you will draw first of all till here, then you will lift your pen, put a point here, and then you will draw something like this. Here you will have to again stop, jump the point, and here again you will have to lift your pen. So in these 4 cases, if you see, right, only one satisfies the condition. Only first figure, here only one satisfies your this particular condition. So that means only one is continuous. This particular diagram is continuous. That is what is meant by this, right? Okay, now this is something which we have drawn graphically. And what if we talk about let's say in terms of math? So in mathematically, what we actually do for continuity is limit at a point. Let's say we are checking continuity at a point A, right? So we will check first of all its limit, that is left hand limit and right hand limit, right? This is how you write, and they both should be equal, and they both should also be simultaneously equal to value of the function at that point. So first of all, understand that continuity is a property of a point, right? You check this particular stuff, it is a property of a point. So you actually check this at a point. So let's say if I'm checking at a point x equal to A here, so how do you have to interpret this? Is very simple. Let's say a person is traveling from this direction, right, and there is another person who is traveling from the rightward direction, right? So if you ask them that, if I ask this person, the right person who is traveling from the right, that as you approach towards C, what value do you see? So he will report you this particular value, right? Let's say this value is FC, right? Let's say if you ask the left person who is approaching C from the left hand side, that what value you see near point C, he'll also say you FC, right? So that means left hand limit and the right hand limit, both persons say the same value, and the value of the function at C is also FC. So that is why it is equal. So here if you see, the LHL, the left hand side person, will also report FC. The RHL person will also report you FC, and the value of the function is value of function at x equal to C is also FC. So all three actually matches, right? And that is why we say this function is continuous. Let's apply the same stuff in the other diagrams. Let's see and how it gels in then. So if we talk about this particular second diagram, let's say again one person is traveling from the left hand side, right? If you ask this person that when you come closer to C, what value you see, he will say that I see this particular circle if he is traveling on this line. Let's say if there is another person who is traveling from the right hand direction, what he will say, he will also say that sir, I am seeing this particular value, right? This particular value they see. Let's say this particular value is y0. Okay, so in the second diagram, both what the LHL and the RHL, that is left hand person and the right hand person, will report you that they see a value that is y0, but what is the actual value at the point? The actual value is something this at this C point, right? So both the limits are equal, but the value of their limits is not equal to value of the function, that is this is not equal to value of the function at point C. That is why I say this is not continuous. I hope I am making clear to you what do you mean by continuity. That is why I again say this is not continuous. Okay, so again the same stuff is happening here. You have two persons here, the one is traveling like this and other is traveling like this. He sees this, he sees this, but the value of the function at C is not defined now. So here in the third diagram, if I talk about third diagram, FC is not defined, right? That is, it is not in domain, is not defined here. Okay, or you say x equal to C does not belong to domain, then also you will have to lift your pen because it is not in the domain anymore. And if we talk about the fourth diagram, let's again see here what is happening. So in the fourth diagram, it is happening that you have a person who is traveling at this, he reports this, but on the right hand side, the person who is traveling will report the other value. In this particular case over here, LHL is not equal to RHL, as clearly evident. So that is why also this is not continuous. Okay, so this is the basic property of continuity. This is how the continuous functions behave. For a function to be continuous, people just have to remember that LHL should be equal to RHL, right? Should be equal to value of the function at that particular point at which the continuity is being asked to prove, right? Clear? Let's apply this concept now in the problems. So this question is like something that where the value of fx is given to you, and it is splitted in two parts, that at x equal to pi by 2 the value of the function is a. When x is less than pi by 2 the function takes this particular value, and for greater than pi by 2 this take this value. You have to check the property of continuity at x equal to pi by 2, and you need to find values of a and b for them, right? This is the condition. So we are actually checking continuity at x equal to, yes, pi by 2. So here what we need, that LHL should be equal to RHL, right, and should be equal to value of the function at pi by 2, and this is actually given. What is the value of the function at x equal to pi by 2? See here, x equal to pi by 2, value is given to be a. That means both LHL and RHL should be equal to your a. This is what you have to do, right? And instead now we need to find the values of a and b for which this particular condition would be satisfied. So first of all, target LHL, let's say if you want to target. So LHL would be written like something x approaching pi by 2 minus, that is you are approaching this function from a less value than pi by 2. So in shortcut, if I have to tell you a shortcut, you just can simply see that since the function is splitted, that this, so what is the value of the function when x is less than pi by 2? You can easily say, sir, this is the value. So rather than solving this limit, as you could have put actually this, right, pi by 2 minus h, you can skip this part and you can just directly put limit x approaching pi by 2 and just put the value of this particular function over here which it will take, right? You can simply do this activity. Okay, so let's solve this particular limits first of all, and we'll quickly see whether this is a 0 by 0 form. Yes, it is a 0 by 0 form. Can you see that? It's a 0 by 0 form. That means LH rule is applicable. That is what I taught you in the other class in limits. So just apply limits rule of LH. So it will say that you can now differentiate numerator and denominator. So if you differentiate, this becomes 3 sine square x and then cos x, right? And this would be, yes, 3 into 2 minus cos x into sin x, right? This is what I can say. Now if you see what you will get, this and this term will get cancelled out, this will also get cancelled out. You are nothing but left with 1 by 2 limit x approaching pi by 2. What you will get? Yes, only sin x. And now there is no problem in terms of limit. So answer that you get for this LHL is 1 by 2. So that means the LHL value is nothing but 1 by 2. This is what we have got. And in fact, if you see, you can directly see that you have got the answer for A. So you can say A is equal to 1 by 2. Why? Because LHL was equal to A, right? Now you need to calculate RHL also, because that now contains B component. And we know that RHL should be equal to A, and we have got A as 1 by 2. So this should be 1 by 2. So now what is RHL? RHL would be written something like this: pi by 2 plus fx, and since again the function is again different from the left hand side function, then we can directly say that limit x approaching pi by 2, just replace this value. No need again to put values like pi by 2 plus h in this particular case also. Okay, so now we need to solve this particular limit this time. Okay, and again check what is the form. Yes, again it is a 0 by 0 form. Can you see this? This is again 0 by 0 form. So this means I can again apply LH rule of limits, that is we can differentiate both of them and the limit will still be same. And if you do this particular activity, what you will get quickly, so this will be b times minus cos x, and this will be divided by 2 times pi minus 2x, that is the derivative of this, and then by chain rule derivative will again be minus 2 here, right? Check again what is the form. Again the form is still 0 by 0 form, right? Again if it is a 0 by 0 form, that means again the LH rule will be applicable. So if I again apply the LH rule and if I cancel the minus, what you have actually got till now, b by 4. What is the derivative of cos x? It will be minus sin x. And what will be the derivative of pi in minus 2x? It will be nothing but minus 2, right? Now it is no longer in the 0 by 0 format, and in fact it is a very simple question to solve. Now this becomes what? b by 8, as simple as that. Okay, and we know that b by 8 should be equal to what particular value? See here, we have seen that LHL should be equal to 1 by 2. So this implies b by 8 should be equal to 1 by 2, or we can say b is nothing but equal to 4. So these are the two values, that a should be 1 by 2 and b should be equal to 4, which we were looking to solve. Got it? Now let's take another problem to understand the concept of continuity. Now fx is again splitted in 3, and it is given that if it is continuous at x equal to 0, you need to find the value of k. So if it is continuous at x equal to 0, what we can say that LHL should be equal to RHL should be equal to value of the function at 0, right? This is what we can say here. Okay, so if this is there, so let's start again with the process at LHL, right? What will be LHL? LHL will be limit x approaching 0 minus fx. So if you approach 0 from the negative side, so understand, if you people are not able to get hold of how I am solving, so this is 0, right? At x equal to 0, what is the value of the function? It is given to be k, right? And let's say I call this function as f1 function and I call this function as f2 function. If you travel to the origin from the left hand side, which function is being used? Yes, x less than 0 function uses f2, and for if you are traveling from the right hand side, the function that you will use is f1. So for this particular case, what I'll solve then, limit x approaching 0 from the negative side, it is function, yes, it is function f2 x, right? So what it will become, let's say x approaching 0 minus, and you will directly replace the f2 function, which is cos of x by 2 times, yes, now this is GIF function. Believe me, I have already told you that GIF makes question much more easier. So do not get confused when you see this GIF sign. Believe me, the answer will be much more easier than you have thought of. So now let's think of how to solve this problem. So your limit is x is tending towards 0 minus, and you have a question which is having GIF. So this is a number which is less than 0, right? What will you get? A number which is less than 0 under GIF? Less than 0, and obviously it's a fraction, not less than minus 1. So this answer would return you minus 1. Just substitute this value over here. That's it. That is what you are required to do in problems like this. So this can be written as x approaching 0 cos of x by 2 divided by minus 2, sorry, and divided by minus 1, which could instead be written as x approaching 0 minus cos x by 2, because you put minus inside cos, it is the one and the same thing, because cos of minus x is cos x only, and now there is nothing to solve. You can directly put cos the value of x as 0. This becomes cos 0 is 1. So the answer to this particular limit is minus 1. Hence the answer to k is question over. Hence k is equal to minus 1. We need not solve for the other part, that is RHL, right? But we can still say that the answer is k equal to minus 1, because it is given that it is continuous at x equal to 0. But still we will solve the RHL just to make sure that you are comfortable with the GIF part. Okay, so now let's talk about RHL. RHL would be something of limit x approaching 0 positive fx. Which function you will use now? Yes, you will use the f1 function now, and f1 function is what? Limit x approaching 0 plus, it is sine jfx divided by jfx plus 1, as we did here in this particular case. So as x approaches 0 positive, that means it is approaching from the positive side, so you can almost say that it is 0.00001. So what will be the GIF of this particular number now? It will be 0. Replace that value over here. So what this will become? Limit x approaching 0 plus, okay, so this limit will give you an answer sine 0 by 1. So this is nothing but 0. Now we are into a confusion that LHL and RHL are both different. Why? Because LHL was giving you an answer -1, RHL was giving you an answer 0, so they don't match each. So we cannot have a finite case. So K cannot be determined is the answer. K cannot be determined because they are not continuous, first of all. So that is the reason I cannot be determined. K cannot be determined. So one of the options that you will find in this particular type of question is cannot be determined, or you can say indeterminate. So when you say indeterminate, that means it cannot be found out. Okay. Now let's take another problem very similar. Now again it is given that the function is continuous at x equal to 0, and you need to find a and b. This is the target. Find a and b. This is the target. So again we can say if this is the point, then at x equal to 0 we can say LHL will be equal to RHL, and this will be equal to what? The value of the function at 0. Right, so there are three components. So what is f0 given to you? F0 is already given to be b. You can clearly see from here x equal to 0 is b, so this is b. So that means LHL should be equal to b, and your RHL should also be equal to b. As you can easily see that in the RHL this function would be used, that is the function towards the right, because x is greater than 0, this will be the role of RHL, and since x is less than 0, this will become LHL, right? So we can easily find this particular value because there is no other parameter over here. So let's start with the RHL first of all. So if I start with the RHL, you will say limit x approaching 0, simply e raised to power tan 2x by tan 3x, right? This is what you people have to solve, and this is very easy limit. If you want to solve this, you can easily solve it orally. I'll tell you a trick, but before that let's go to the process. It says tan 2x, you require 2x here and 2x here, right? Then this formula will become, and similarly for tan 3x you will require the same activity, 3x here and 3x here, right? So if you solve this, what answer you will get? This becomes 1, this particular value becomes 1, x and x cancels out, and you will get e raised to power 2 by 3, and this should be equal to b, right? So you have actually got the answer for b. The answer for b is nothing but e raised to power 2 by 3. And a trick that you people can remember, that if you get something of the sort limit x approaching 0 sine ax by sine bx, the answer is simply a by b. Treat it as if you have cancelled sine and the x term. Similarly, if you have something of the sort limit x approaching 0 tan ax by, let's say, tan bx, the answer would be straight away a by b. So these tricks can be remembered by you people, right? This is trick. Okay. Now coming to the part of the LHL, we still have to solve the LHL component. So LHL now has a in it, and that is the reason we need to find it. We know now that LHL should be equal to b, which we have already got as e raised to power 2 by 3. What will be the value of LHL? LHL will become 0, limit x approaching 0, minus 1 plus mod sin x, and this is what you will write, a by mod sin x. Okay, so now irrespective of 0, what value you will get, let us see. So this is an exponential function, and first of all figure out what is this form of limit. So again I can say this form of limit is something 1 raised to power infinity form, Why? Because if you put 0 minus, this will be sine 0. Sine 0 from a negative side will be a negative very small number, but since it's a modulus, so it will become positive and 0. So this will be 1 and 0 here. So 1 raised to power infinity form. We know that if 1 plus x raised to power 1 by x, the answer to this particular limit becomes e if this x tends towards 0, right? We have done this in limits. So same thing is happening here. Here the role of x is being played by complete this sin x. So you can just say that this particular value is nothing but e raised to power a. Simply, that's it. So this value is nothing but e raised to power a, and we know that this is 2 by 3. So that implies a comes out to be 2 by 3. So this is the answer we are looking for. So b is nothing but e raised to power 2 by 3, and the value of a that you should get is 2 by 3. This is the answer, and this is how you solve this particular problem. Now next problem says that fx is a continuous function from 1 to 3. So it is given that fx is continuous. This is given to us, and this is also given that it is continuous in the range when x belongs to 1 by 3. So in 1 by 3 you have the continuity here, that the graph will be drawn without lifting the pen. If fx takes rational values for all x, it says that fx takes rational values. I'll come back this point, that what do you mean by this particular statement rational values, a bit later, for all x, and it is given that f2 is nothing but equal to 10. Then you are asked to find the value of f at 1.5. This is the target, right? So how do you solve this? So at the first moment it looks like a very tricky problem, but believe me, this is oral. I will not be able to solve it, in fact, because there is nothing to solve in this. Now let us come back to this particular point when it says that fx takes rational values. So what do you mean by rational values? So let's say if we draw something on a scale, let's say this is the scale, right? And you have a line. So it takes, let's say, values from this. Let's say this particular line is y equal to 3 line, right? And this particular line I will rather say, let's say, y equal to 2 line. So between these two lines, that is y equal to 2 and y equal to 3, so these two are rational numbers, right? Can you say that these two are rational numbers? Or for that even matter, these two could be, I will explain then, you could take them to be 2.1 and 2.2 also. That's not a problem. But let us first of all understand by 2 and 3. If they are rational, so between the mathematical logic says between any two rational numbers, lies infinite irrational numbers. This is a very important concept that you people should know. So between two rational numbers there are infinite irrational numbers on a number line. So whether it is 2 or 3, or whether it is 2.1 and 2.2, so that is between 2.1 and 2.2, right? So there would be infinite irrational numbers here, right? So if it is given that it takes only rational values, so that means it cannot take two different rational values. So from this I can say that fx will not have greater than 2 or equal to 2 rational values, because if it takes two different rational values, then definitely it will take at least one infinite value in between, which is not happening. So this actually says that fx is a continuous function. Is continuous, in fact it is a constant function. That means its value remains unchanged, and since it is given that f2 is equal to 10, so that means fx is nothing but 10 only. Whatever value you put, it will just return you 10, which is always rational. So that why it will not be able to take any irrational value in that way. So if it is asked f1.5, so answer would be nothing but 10. So this is the answer you people should look into. Okay. Okay, the next question that we are going to solve is find the points of discontinuity in a composite function, right? So discontinuity in the composite function. Why it is a composite function? Because what is given to you is a function of t, right? Now this is t, and now itself t is given to be in form of x. So let's say t is given to be f dash, not so t now is given to be in terms of, let's say, hx here, right, which is another function in terms of x, which is given by 1 by x minus 1. So this machine is a composite function where you will put this value of t. So if you combine these two, actually you are being asked f of h of x. This is the function that you are being asked. And if we draw the machine for this particular composite function, what machine you will get? Yes, the first machine that is going to work is h. The second machine that is going to work is f, and then you will get your machine of f of h of x, right? So what is f of h of x? Can you tell me? So let's solve this. ft then will reduce to what? This will reduce to 1 upon, you can say, t square plus 2t minus t minus 2, and this will reduce to what? 1 upon t plus 2 into t minus 1. This is what will be the middle term splitting of this. And now just replace the value of t. You know that t is equal to 1 by x minus 1. So if you replace this, what it will give you? Calculate. Okay, so if you resolve this particular expression, then you should get your answer by putting this value of t here as x minus 1 square divided by 2x minus 1 into 2 minus x. This is what you will get, right? This is your f of h of x. Now I can say this. So if somebody asks you at what values of x this machine will not work, so your answer would be that this will be discontinuous at x equal to 1 by 2 and x equal to 2. Why? Because they are not defined in the domain. They are not in domain. They are creating problem in terms of domain, not in domain. Why? Because the denominator becomes 0 at these two values. Okay, so if you answer me that answer is 2 points, that is which 2 points? That is x is equal to 1 by 2 and x is equal to 2, then I would say answer is wrong. You will get -1 in the paper. Now understand again from the concept of composite function. For a composite function, that is f of h of x, this machine should work and this machine should also work, right? This is the criteria that both of the machines should work. So let's say this is the first machine, which is this hx, right? What is the condition here? This is 1 upon x minus 1. So this machine will not work when x is equal to 1. This is the problem with this particular machine, right? And by solving, you have actually got this particular machine over here as this particular machine. So this second machine was simpler, which you have actually found. So the answer for this particular, you have actually got this. Let me write d here. Now you have actually got that this is not work at at 1 by 2 and this will not work at 2. But what about the first machine? Can you see that this will not also work at x equal to 1? So if x is equal to 1, you will not be able to travel further. So that means x equal to 1 is not also in the domain, right? For this particular function, x equal to 1 is a point of discontinuity because the first machine will stop to work. If this machine stops working, this machine will not get any input, hence you will not get f of hx. So there are 3 values at which your machine will be discontinuous. So that is answer comes out to be 3. So the values that will be creating problems, that x should not be equal to 1 by 2, 1 and 2. So these are the 3 points of discontinuity. Okay, I hope the question is clear. This is one of the very good questions that is being asked in the papers, and do revise this because this is something which is very common in entrance examination, these kind of questions. Discontinuity of composite functions. The next topic that we have to study is type of discontinuities. So these are the 3 discontinuities that you people should remember, right? Rather, I should say type of, not continuities, but type of discontinuities. So we are studying type of discontinuities this time round, right? Type of discontinuity. So if we talk about type of discontinuity, this graph is discontinuous because you will have to lift your pen here, you will have to lift your pen here, and obviously you will have to lift your pen for this. So this particular stuff here is known as removable discontinuity. I'll tell you why. This is called removable discontinuity. This is called jump discontinuity because you can say that the function has taken a jump. Now even starting from here, it has just moved to here. And this is called infinite discontinuity because both the limits are tending towards infinite, right? And let's see the mathematical definition of all these 3. Here LHL is equal to your RHL. Why? Because this person who is coming from this side will report this particular value. The person who is coming from this particular side will also report that he sees this value. But the problem is that they are both not equal to value of the function at x0. So this is why I say this is a removable discontinuity. For this to be removable, that means, as the name suggests, you can remove the discontinuity. So by what method you can remove this discontinuity is very simple, that just declare that fx0 is equal to c. Let's say if this value is c here, I'll just declare that fx0 is nothing but c rather than this particular value. If I change the value, if I change the value of f at x0, this can become removable. Okay, so it could become continuous. That is why we call it as removable discontinuity. Remember that for this removable discontinuity, LHL should be equal to RHL, right? And they both should be finite values, not infinite values. So let me correct it in a way that here LHL should be equal to RHL and they should be equal to a finite value. Got it? Clear? Okay. Now let's take the jump continuity part. Can you tell me why it is called jump? Because it has taken graph has taken a jump here. Now if a person who is traveling from the left hand side, it will report this particular value, let's say A, right? And the person who is traveling from the right hand side, he will report that he sees this particular value, which is definitely not A, which is B. So in this case you can say that, sir, LHL is not equal to your RHL, right? So in that, when will in case of jump continuity happens when RHL and LHL are not equal, though they both finitely exist, right? You are getting finite values for each of them, but these values are not equal, though both finitely exist. So that becomes what? Jump discontinuity, and it is irremovable. You cannot remove this jump discontinuity, right? This is a irremovable discontinuity. The third what we have to do, as you can directly see from the question, here also LHL is not equal to RHL, right? Because both are infinite. So we will say that this is an infinite discontinuity when either one of them is infinity, because then we will not be able to compare it with the other particular quantity, and obviously this is also irremovable, right? So out of these three, only one particular kind of discontinuity can be removed, that is irremovable. For this to happen, LHL should be equal to RHL, and they both should be first of all finite. Then we can make fx0 equal to the value of RHL or LHL to make it continuous. Got it? Now let us take a question to highlight types of discontinuity. So here a function is given to you that fx is equal to modulus 2 signum function 2x plus 2. So you need to tell that if this is a discontinuous function, then what sort of discontinuous function it is. Okay, so first of all, just revising that what is a signum function? Signum x. So signum x is, it will return you 1 for x greater than 0, it will return you 0 for x equal to 0, and it will return you minus 1 for x less than 0. So what will be the definition of signum 2x? So signum 2x will do the same activity. It will return you 1 when 2x is greater than 0, it will return you 0 when 2x is equal to 0, and minus 1 when 2x is less than 0. And if you see, this corresponds to the same property that is written here, that is, it will be x greater than 0, this will become x equal to 0, and this will become x less than 0. So signum 2x will return you these three values depending on these three values of x. So now let's say if I complete this particular function, so modulus 2 times signum 2x will give me three answers. Which one? It will give me 2 when x is greater than 0, it will give me 0 when x is equal to 0, and it will give me minus 2 when x is less than 0. Wrong. Why? Because see, there is modulus here, so this will also now give me 2, right? It will not return me a negative value. And if I talk about the complete function, then 2 signum 2x plus 2, So it will give me how many values? This will give me 4 when x is greater than 0. It will give me what? Not 0, 0 plus 2, right? So it will become what? So these are the 3 values that you will obtain, and in fact if I can club them into 2 only. I would say that 4 when x is not equal to 0, and it will take 2 when x is equal to 0. So can you tell me the diagram of this particular function now? If I have to draw them on scale, let's say this is your x-axis and this is your y-axis. So the answer that we will get is, let's say it takes the line y equal to 4, then it takes a break at x equal to 0. Why? Because at x equal to 0 your answer becomes what? Your answer is nothing but x equal to, at x equal to 0 your answer is y equal to 2, right? This particular value is 2 and this particular value is 4. So what kind of discontinuity is? We know that we have to lift your pen here. What kind of discontinuity? Yes, this is something removable discontinuity. Why? Because the pen is being lifted, so this is the point of discontinuity. This is point of discontinuity, which is, that means x equal to 0. What is the value at LHL? LHL takes 4. What is the value of RHL? RHL is also 4. So both of them are equal, but they are not equal to value of the function at 0, which is 2, right? So now we can make this removable, or we can remove this discontinuity by supposing that we're declaring that f0 is nothing but equal to 4. Then this becomes continuous again. That is why I say this is removable discontinuity. So this is differentiability. So let us study differentiability. What do you mean by differentiability first of all? So if I talk about graphically, right, again, so graphically differentiability tells you smoothness of the curve, how smooth the curve is behaving, smoothness, right? So it will immediately tell you whether the graph is smooth or it is having a sharp end, right? This is the physical or the graphical significance of differentiability. For example, if I say y equal to mod x, right? So we know that mod x is of the form v. So can you see that at this particular point, right, it takes a very sharp turn, sharp edge is there, right? Sharp edge is there at x equal to 0. So that means at x equal to 0 graph is not differentiable. This is what I can say if I know any diagram. For example, if I draw something of this sort, let's say, right, if this is a pointed edge over here, though right now it looks like a smooth curve, right? It is very smooth. So if this is smooth, then this is differentiable at this particular point. Whereas if you draw something like this, so now here it is a sharp edge, pointed edge. So if this is pointed, right, so that means not differentiable, ND. Okay, so if the graph is smooth, so for example the sin x curve, right, they are all smooth, so that means they are all differentiable. It is, I would say that this graph is completely differentiable. Got it? So this was something about on the geometrical front or the graphical front, right? They are differentiable first of all. Okay, so if we have to talk about the mathematical definition, so mathematical definition says left hand derivative LHD should be equal to RHD, as you people must have studied it, right? LHD should be equal to the RHD component. So how do you calculate LHD? Is limit x approaching a minus f dash x, right? This is what you want, derivative when the value is less than a. We are checking for continuity differentiability x equal to a, right? We'll get into depth of what do you mean by differentiation, because differentiation is nothing but slope of the tangent at that point. Though we'll use that property in application of derivatives, we are just studying what is differentiability. So how you solve this? So if you want that, you know that f dash x is slope of the tangent, right? So what is the slope of tangent? Slope is nothing but y2 minus y1 by x2 minus x1. So if you just apply this in a question of limit, let's see what it will become. I say h approaching 0, I say fa minus f of a minus h. So this is something y2 minus y1. Can you compare this with this one? And if I divide it by their inputs, that is a minus h, this is nothing but left hand derivative. This is how you calculate left hand derivative. If you compare, that a will get cancelled out and you will actually get what is the value that you should remember. This particular value is the left hand derivative. Similarly, you can calculate also the RHD. RHD also can be calculated in a very similar fashion, right? Again, if you do limit h approaching 0 and one point is f of a plus h minus fa, so this is y2, this is y1 upon a plus h minus a, you will get your answer for yes, RHD also. Got it? So this is how you should remember, because this is the concept involved in finding the left hand derivatives and right hand derivative. See here, this is what exactly is written over here. So these two values should be equal, right, for a function to be derivative at a point. And again, derivative is a property of a point. You check derivative at a point. Okay, clear? Now let's see different cases involved in differentiability. So if you have that fx is a function whose RHD is coming out to be L, right? So this is L, and this comes out to be LHD comes out to be M at a particular point A. Okay, this is given to you. So RHD is L and LHD is M. This is what you are given. So if both of them are equal and they both are finite, then the function will be differentiable as well as continuous as well, right? So this is something very important that you people have to understand. So if I give you that a function is differentiable, that implies obviously it is continuous. So if you have proved that the function is differentiable, then it is already proved that the function is continuous. But vice versa, if I do, that is not true. Vice versa means if you have proved that a function is continuous, right, it may or may not be differentiable, may or may not, right? You cannot say for sure whether it will be differentiable or not. Okay, this is what I meant by here. Famous example that you can understand is mod x. So mod x is a continuous graph. You need not, pull your pen up for drawing this, but it is not differentiable at this particular point. Got it? So remember, a continuous function may or may not be differentiable, but a differentiable will definitely be continuous. No need to prove it. The other definition is that if L and N are not equal, both of them are not equal, but still they are finite, right? That means left hand derivative is some other value, right hand derivative is some other value, then obviously they are not differentiable, because we needed RHD and LHD to be equal, but it will still be continuous. Let's say for this particular diagram. Okay, clear? So even if you want to remember, again mod x diagram will come into play, right? This is the mod x diagram. If you take the LHD, right, LHD will come out to be -1. If you take the RHD, it will come out to be 1 at x equal to 0, right? Both of them are not equal. RHD is not equal to your LHD, we know this fact, right? Then, but still they are both finitely equal. That is why I am saying the graph will be continuous. Okay, and the third category will be when at least one of them is infinite, right? That is either L or M is infinite, then it will be non-differentiable for sure, but we cannot say anything about the continuity. Then you will have to individually check for the continuity. Then you will have to talk about whether they are, by proving LHL equal to LHL or RHL or not. Though this case 3 is the least asked case in JEE Main, so we are not focusing too much on it. You should just revise these two cases, that if LHD is equal to RHD, it is differentiable and it is continuous as well. If LHD is not equal to RHD but both are finite, then it will be non-differentiable but continuous. Okay, now let's apply these properties into questions. Another very important property that you people should all remember is that if, let's say, f and g are two functions and this is given to be differentiable and continuous, right, and at the same time this is also given to be differentiable and continuous to you people, right? So if it is asked that what will be f plus g at, let's say, x equal to a, right? So if both of them are differentiable and continuous, f plus g will also be differentiable and continuous at x equal to a. Similarly f minus g, similarly f into g, and similarly f by g, provided that f ga is not equal to 0. Very important stuff, remember this. Apart from this, you need to remember that all trigonometric functions, trigo functions are continuous in their domains, continuous in their domain, right? When I say continuous in their domain, so at 10x, if I talk about 10x, right? So 10x here, x equal to pi by 2 does not lie in the domain. It cannot take x equal to pi by 2. So we will not talk about continuity at x equal to pi by 2 because it is not in the domain. So but otherwise it is continuous in its domain. Apart from that, all polynomials are continuous. Just remember this. No need to prove this. So they are continuous as well as differentiable. No need again. Okay. Similarly, all the trigonometric functions are continuous plus they are differentiable also. Remember this stuff again. Logarithmic function in its domain is again continuous and differentiable. What I mean by domain, when you say x greater than 0, if I talk about log x. Exponential function e raised to power x or a raised to power x, they are again continuous plus differentiable, both. No need to prove. Something of the sort divided by something, so polynomial, let's say, and there is another polynomial dividing it. So if polynomial by polynomial is there, it will again be continuous plus you cannot say differentiability. You will have to check for the differentiability part, but it will definitely be continuous provided that this denominator polynomial, let's say denominator polynomial, is not equal to 0, right? Otherwise polynomial by polynomial will also be a continuous and differentiable function at that particular point. Remember this stuff. So this question asks you to check the differentiability of the given function at x equal to 0. So for differentiability, we need that LHD should be equal to RHD. And what do you interpret by LHD then? LHD would be nothing but, let's write LHD, limit h approaching 0, f of 0 minus f of 0 minus h, right? Just a smaller value than that, and divided by h, right? Let's start putting these values now here. So it will become limit h approaching 0, f0 will be nothing but 0 minus f of, I can say, nothing but minus h by h. So this becomes, reduces to limit h approaching 0 minus of f minus h by h. Okay, now start putting the value. So I can take the minus outside and this will reduce to what? F of minus h will become what? This particular value, by replace x by h here. So you will get minus h into sine of minus 1 by h, right, divided by h. You can see that this h and this h gets cancelled out and you are left with minus sine minus 1 by h, the input. This minus will be taken outside and this will get cancelled by this outside minus sine. So this reduces to sine 1 by h, right? And since as h approaches 0, I can say that as h approaches 0, 1 by h will approach infinity. So this actual question becomes that it is sine infinity. So this is the LHD that is coming out to be. And we know that this is an oscillatory function. Why we call this as an oscillatory function? Because we are not sure of what value it will take. We just only know that this particular value belongs something down the line between minus 1 to 1. So that means LHD is not finite here. And since LHD is not finite, the question is over. It is not differentiable. I cannot say that this function is differentiable at x equal to 0, because for this to happen, what should be the case? Yes, for this to happen, the answer should be finite values of LHD and RHD. Okay, now let's see. Other question on the differentiability is given that function fx is something like this, and we need to find f. It is given that f dash x exists finitely for all x, then find b and c. So if f dash x exists, that means derivative exists, that is differentiable exists. We know that this is a polynomial, so for polynomials we do not prove anything, and we know that this is a polynomial, so we will not need to require prove this differentiable. But where we will check for differentiability is at x equal to 1. Why? Because here definition of function is changing. So wherever the definition of function is changing, then at that particular point you will be required to check whether it is derivative or differentiable or not. So for this to happen, you require LHD is equal to RHD, right? And now I'll tell you a very shortcut for this particular question. Okay, just let's listen to me very carefully. So you know that LHD is a polynomial. Let me just highlight this for you. This is a polynomial and this is a polynomial. I already told you that polynomials are always differentiable and continuous in their domain, and if you are asked to find LHD of this particular question, just differentiate the left hand side function. I am repeating, if this is a polynomial, right, and LHD is to be asked, just differentiate. This value would be what? 1. So LHD at x equal to 1 is nothing but 1. Just differentiate it and put x equal to 1. For RHD, what you will do, differentiate this value, what you will get? Yes, you will get 2x plus b. You just put x equal to 1 in this. If you put x equal to 1, you will get 2 plus b. And now since you know that LHD should be equal to your RHD, that's it. So what you are required to do is 1 is equal to 2 plus b. This gives you answer b is equal to minus 1 straight away. Right? Straight away answer b is equal to minus 1. Now you are left to find c also. Right? You can apply this. Remember, this is a trick method, shortcut. Not I should say trick because there is no trick. This is completely conceptually correct. But yes, a shortcut. Right, this is a very good method to solve quickly in the engineering exams, but never solve like this in the CBSE board, believe me. So if you are solving this in the CBSE or let's say your boards, this is complete no. Never apply this in these kind of tricks here. You will have to solve completely like 1 plus h, 1 minus h. Now we require also c, right? We require c. For c, that means one more condition. We require one more condition here. Where will we get this condition from? Think of it. Yes, we can get this condition from continuity as well, right? So because since it is differentiable, we can say that this function is continuous as well. So how do you apply continuity? Again, a very small trick. Let me tell you how. So if this function is continuous, okay, so what you will be required to solve then? You want LHL should be equal to RHL should be equal to value of the function at 1. What is the value of the function at 1? So check when is x equal to 1. X is equal to 1 here. Put x equal to 1. So f1 is nothing but 1. You want LHL and RHL to come out to be 1. Okay. So limit x approaching 1, x is equal to limit x approaching 1, x square plus bx plus c should be equal to 1. This is obviously 1, nothing to prove. And here if you just put the value, you will get 1 plus b plus c is equal to 1, or I can say b plus c is equal to 0. This says c is equal to minus b, and since we have already got b here, so the answer to c becomes yes, 1. So this is the answer we were looking for. So net answer for both the values will be that b is equal to minus 1 and c is equal to 1. So these questions are solved something like this. So if there are two parameters, let's say for example in this particular case there are two parameters, right? So for two parameters you will require two conditions. Two parameter means two conditions. You can easily get them from this kind of question. So one would be from continuity and the other one would be from differentiability, right? Okay, let's take the next problem. It says which of these two functions is differentiable. You need to check which one of them is differentiable, right? Okay, again I'll teach you a very shortcut method of finding this particular case. So let's say I am solving for the first question, which is fx is equal to cos of mod x plus modulus x. Now first of all, before I go further, just tell me how we can split this. I can split this as cos of minus x when x is less than 0, and cos of x plus x for x less than greater than equal to 0, right? Or if I still modify it, because I know cos of minus x is nothing but cos x, so this becomes cos x minus x, right? And cos x plus x for x less than 0 and x greater than equal to 0. Now you want to prove whether this function is differentiable or not. So if you want to prove a function is differentiable or not, the first step, rather than to go straight away for differentiation, you should check whether it is continuous or not. Okay, so how do we check the continuity of this? Since again you can see this is a two layered function because it is having trigonometry and algebra. Algebra is, this polynomial is continuous, cos x is continuous, so their difference will also be continuous, no problem. So if I want to check for continuity, right, continuity, where will you check? We'll just check at x equal to 0, because at x equal to 0 again the function is changing its definition. For x less than 0 it is something else, for x greater than 0 it is something else. So if you want LHL, what will be the value of LHL? No need to put limit because there is nothing in the denominator, so no need in investing your time in putting the limits. So just put the value of x. If you put the value of x equal to 0, what you will get? 1. And what will be the value of RHL that you will get? You will again get 1. So that means it is continuous. That is not a problem. Now check about this differentiability. So for differentiability, what you will do? Again, this is a trick method that I am telling you. Okay, so now no need to again go into the lengthy method of finding differentiability, just differentiate. So what will be the LHD? Differentiate this particular value here. This will become minus sin x plus 1, and or in fact I would rather say you write something like this. So rather than saying LHD to you people, I would say the derivative f dash x can be written as two functions, that is minus sin x, and this will be minus 1 for x less than 0, and this will be for x greater than equal to 0. Now you want to find that whether this is differentiable or not. You want to check this as at x equal to 0. For this, just simply put the value of x equal to 0 here. So if you wanted to find LHD at x equal to 0, you just simply substitute the value of x from here in this particular expression here. So what this value will come out to be then? This will be minus 1. And what will be the value of RHD then? Just replace this value here, right, from here to here. Okay, so this will become what? 1. Since LHD is not equal to your RHD, that means this is not a differentiable function. As simple as that. No need to go into the lengthy calculations. Got it? Clear? Similarly, try and solve, let's say, for this particular case. So let's say question 2 if we talk about. So again I can say fx is a combination of two functions. Can you tell me very quickly how? So sin mod x, right? So sin mod x will return you what? Sine of minus x for x less than 0, and minus minus plus, this is for x less than 0, and for positive values of x, yes, mod, whether you place mod or not, it will be immaterial. Now this minus sign will happen to be something of this sort, minus sin x plus x, and this will be sin x minus x for x greater than equal to 0, and this will be x less than 0. Now you people tell me, can you solve this now question orally for me? Check the continuity at this particular function, continuity. So for continuity you just need to put what? Here for continuity put x equal to 0. So LHL is, tell me the value LHL. Yes, 0. What is the value of RHL? 0. So yes, the function is continuous. Now let us check at differentiability. For differentiability, let us differentiate the function first. Since why we are differentiating, I'll repeat, because we know that this is a differentiable function, this is a differentiable function, sum of differentiable function will also be a differentiable function. So what is the derivative here? Minus cos x, and this will be plus 1. This will be what? Yep, this will be minus cos x, this will become plus cos x. Yeah, sorry, this will be minus and this will be positive, right? And this will be minus 1. So this is for x less than 0, and this will be for x greater than equal to 0. Now you need to find differentiability at x equal to 0. So what will be the value of LHD? Just simply replace x equal to 0 in this particular component as you case do in limit. So why we are doing this? Because you have already differentiated it. Now never apply the concept of LHD. It now becomes just a limit question. If you are not able to understand, just stick to the basic, differentiate it, and now just simply put the values. So if you put the values, what answer you will get? LHD 0, because cos 0 is 1. Similarly, find the value of RHD now. The cos 0 is 1, 1 minus 1 is 0. So this case gives you that LHD is equal to RHD. Hence question 2 is differentiable, whereas question 1 is not differentiable. So this is how quickly solve a tough problem on differentiation orally. Rewatch the video again to get hold of this particular concept. So this problem says find the number of points in X belonging to 1, 2, 3, right, where fx is equal to a raised to power JEF x square is not differentiable, right? You need this to happen. So this question is completely based on the JEF function. If you understand this, you will not have any problem solving this particular question. So let's say when the JEF problem is discontinuous, tell me this first of all, right? So as you can see, this is the graph of JEF function, step up function, right? So you can see that this graph is discontinuous as integer points, discontinuous at integer points, and this is how you actually remember this incorrectly. I should not say at integer points, rather I would prefer to say integer inputs. This is the problem of understanding here. You should not say integer inputs or integer points, rather you should add integer points, because this is discontinuous at x equal to 1, 2 and so on, and this is JEF x, right? Now what we are given here is the function. Let's say I'll take gx as this is given to be gx x square, right? So this will be discontinuous. If this is to be discontinuous, then the input should be integer, right? So most of the students generally do an error that they start putting x equal to 1, x equal to 2 and x equal to 3, and they say that these are the 3 points of discontinuities and answer would be 3. So first of all, this is wrong. Why? Because you are asked to find between 1 and 3. So the correct answer in that particular case would have been x equal to 2, but still this is wrong. Why? Because you are thinking from the perspective of this, that they are discontinuous at integer points, whereas the concept is they are discontinuous at integer input. So think of when will x square become integer? When will x square become integer? Because at that particular point this will be discontinuous, and if the graph is discontinuous, then this means this is non-differentiable, right? Clear? So that is why I am just trying to prove the graph as it is discontinuous at those points. So x square becomes integer at takes 1 at x equal to 1. So this is first point of discontinuity, but it is not included, so we will not talk about it. Then x square can become 2. Yes, now it takes completely x is equal to, so this could be done when x is equal to plus minus root 2, but still we just take plus 2 because we are to take values between 1 and 3. Again I am reiterating what do I mean by integer inputs, that if this is the GIF, this will become discontinuous whenever it takes integer value inside. So that is the reason, since the input is x square, so I am trying to check when will it take integer value. So x square can be equal to 3 again at x equal to root 3. I hope you are getting my point. X square is equal to 4, this takes place at x equal to 2. X square is equal to 5, again this will be discontinuous at root 5. Similarly it will be taking 6 at root 6, it will also take 7 at root 7, it will take value 8 at root 8, and then you will get value 9 when x is equal to 3, right? So we need to stop here. Why? Because your domain is from 1 to 3 and you need not include these two values. Why? Because these are the boundary values which are not in your particular domain. Check here. So how many values are there that are satisfying that this is not continuous? 1, 2, 3, 4, 5, 6 and 7. So 7 points of discontinuity. So your answer is 7 points of non-differentiability are there. Why I am saying non-differentiability? Because I know if the graph is discontinuous, it will definitely be non-differentiable, and the JEF function in its domains, for example if I talk about 0 to 1, so what is the value between 0 and 1? It is a straight line, right? You can see this is a straight line. So this is differentiable, this is differentiable, this is differentiable, no problem, but it is not differentiable when I talk about 1, when I talk about 2, when I talk about 3. It is not differentiable at these points. So I would say if these are the point of discontinuities, so these are the points of non-differentiability also, and this is how you solve this problem. I hope this is clear now. Okay, so by this we come to the end of this particular chapter. We did something on the conceptual level of continuity and differentiability, and some questions based on individually and some based on both the concepts. Just revise these particular questions, and I believe that this will be more than enough for your JEE Mains level. You need not be required to solve, or in fact not solve, but in fact there is no need to study any further concept beyond the what I have taught in the videos. And as usual, I will be sending you the worksheets. Just solve them and move ahead. What again I am focusing is on do NCERT exemplar, so that if you do NCERT exemplar, you are simultaneously preparing for boards as well, because this is the first chapter that we are covering today for as per se your board syllabus also, that is the class 12 syllabus. So you will be doing two things at the same time. This is what is called strategy, and this is how you should prepare. Okay, apart from that, if you are having any problem in the NCERT level, I told you earlier as well, just go on the channel, search for the continuity and differentiability on the channel, and you will be able to get to the exercise and the question number that you want to find, and there will be a video available for that which you can see and move ahead. Okay, I hope the lecture was clear to you. See you tomorrow with a new topic. Good night till then.